Thank you. The reason I'm TBA is because I've taken over at the last minute for Fred, and I'm not going to be giving Fred's talk because he didn't give me one. So I've come up with something that I want to share with you all, partially based on what I've heard at this conference so far. So I was really impressed with our plenary speakers, and I don't know how many of you guys went to the public meeting last night as well. It was really compelling, and it was really amazing to hear the stories of, can you guys hear me okay in the back? Okay. I was just really inspired to hear some of the same topics discussed more for the public. And it got me thinking about the work that I've been doing trying to put some of this science into action. So I'm going to share a little bit of that with you. So if you've been following my work in disease ecology or restoration or taxonomy, you might be a little disappointed. You can go. But this is still also, I think, really interesting, and I hope you'll enjoy a little bit of a break from the hard science talks we've had here since this is the very last talk. So thank you for staying. I decided to call this Supporting Science, Saving Seagrass, and Enhancing a Temperate Reef. And want to demonstrate the role that landscape architecture could play in greening coastal urbanization and improving seagrass habitat. So just a little bit about me. I started out my career in urban planning. I got my degree in community and environmental planning and moved quickly into landscape architecture, feeling that urban planning didn't give me enough resolution in my work. Got a degree in landscape architecture, and then that wasn't enough, so I got myself a certificate in restoration ecology, all in my undergrad. A little ambitious. Still wasn't all that satisfied with my work in restoration ecology as an undergrad. Got into seagrass ecology and specifically into the disease ecology. So if you're familiar with my work, that's how it came about. My master's work and all of my undergraduate work was at the University of Washington in Seattle, where they were really supportive of this progression, which I didn't realize how rare it was until I went to Australia. I got a PhD scholarship, went to Australia, and realized how these two fields really weren't communicating with each other all of that much. My work in Australia focused around seagrass resilience. I've been studying propagation and disease resilience of Australian seagrasses in temperate Australia, which you heard my whole bag about taxonomy. Anyways, then moved back to Seattle and was promptly given a position of faculty in the landscape architecture department, which really shocked me because I actually haven't received my PhD yet. I'm still a student. But they really saw the value of connecting the science and the design. Of course, going back to America was not the easiest thing to do at this time, right? But over the course of the time I was gone, Trump had been elected, and quickly and rapidly we've seen a decline in protection of areas, especially coastal areas, seem to be a target. So we just get like one story after another, don't we? It's just a depressing time to be working in the environment. And I know I've talked to a lot of my students, I've talked to a lot of other researchers here and at this conference, and that it's really clear that a lot of political problems are being driven by ecological crises, and yet we still, even though we have a lot of science, we haven't really been able to make any difference. So I mean, this just goes on and on. I mean, every day. These are just from today's headlines alone that we can see. You know, we just sort of this onslaught of the negativity, and this will be coming out Wednesday in Nature. Okay, this is going to cause some stuff. If you haven't read all this online yet, it's worth a read. It's gaining attention. So, in landscape architecture, I found some real optimism. My students are really keen to learn more about design and to put that into their design work and make some real change in the world. So I'm finding a role for myself as a scientist leading designers to good science, how to read science, and utilize science in their design projects. And I'm beginning to believe now that to adapt to and mitigate climate change, we're going to need this multidisciplinary collaboration. And I think landscape architecture is actually a really great house for this, because they're trained in soil science, botany, drainage, engineering. The role of the landscape architect really is as a hub for all of these stakeholders in the real built world and for real projects. So there's a lot of power there, and yet landscape architects are trained to receive information and put that into their designs. And I'm going to show you a little bit what kind of power we can get from that design element. Okay, So last quarter, I had this great opportunity to lead a studio of 5 graduate students and 2 undergraduate students in developing what we called an octopus's garden. And this project arose because a science student who had taken the landscape architecture course from my collaborator, Ian Robertson, came back to him and said, look, we've got this project. The State Department has given $500,000 to the Scuba Alliance to build an artificial reef. And we really believe science is best demonstrated through design. So they came to us. Ian promptly turned to me and said, oh my gosh, can you help me? And we formed this really great studio. I'm going to share some of what we did. So students, the way that we work through a project isn't through background information, but through what we call site analysis, which is essentially the same thing. So here we are. This is Washington, where Seattle is, just south of Canada, north of California. And in Washington, we have this beautiful bay here in the middle of 2 mountain ranges. So there's a whole lot of water. You can see all of the rivers that feed in, and it really is this sort of nursery ground, is this just really beautiful green oasis, or it has been historically. In fact, I think Jacques Cousteau said it was the second best diving in the entire world here. So there it is. And we affectionately call this area the Salish Sea, if you've heard of that before. I should say all of these maps and images have been developed by my students, led by Jess Petrano and Rachel Wells. I want to make sure and give them credit because I realize in the end I give credit to all of our stakeholders and not my students, and that's terrible. Couldn't go back and fix it. So here we are. This is Seattle, like right about here. And I'll be talking about a site. Our project site here is called Redondo. And this is Puget Sound in the U.S., and then the Strait of Georgia extends up into Canada. So this really is this place where the Pacific Ocean comes in. If you've heard of Friday Harbor Labs or San Juan Islands, that's here. And so this is a highly urbanizing area, especially along this east coast in Puget Sound. And it's home to, I want to make sure that I acknowledge that it's home to a large and active community of Native people who are generalized as the Coastal Salish. And they had a rich history on the water, transportation through the water and really living on the coast and kind of hopping around these islands and utilizing them seasonally rather than building on the land or deforesting to build their communities as such. And the salmon emerged in their literature as one of the most important organisms to their culture. It's a food source, it's a spiritual source, and it turns out through science we've demonstrated that the salmon are actually part of what makes our forests so healthy because they are anadromous, which means they are born in the rivers, they go out to sea, and then they come back. And when they come back, they die. And when they die in the water, it actually leaves a nutrient pool that has helped to enrich the forest. So it's a spiritual and ecological beauty, I'll say. And the Coastal Salish tribes are really active today. I don't want you to think of them as something long ago. This is a really important group of people, and I just wanted to make sure we properly acknowledge their role in protecting those ecosystems for so long. So one of the first things my students were excited to do, they love to create images, and they created this gorgeous food web. And they did this by interviewing several really prominent ecologists, coastal ecologists, at the University of Washington. I'm like 2 minutes out. Oh, no. Okay, so anyways, we have a food web. We have the salmon. I told you a little bit how they work. Their nursery ground is the seagrass. So seagrasses in our area are highly protected. We have one of the best, I think, monitoring programs that's gone on since, it's over 20 years now of data. Every single year they go out on a monitoring expedition, and it's statistically modeled so that we can assess a 20% decline on any site over a 20-year period, I believe. It's home to a lot of really cool fauna, and our giant Pacific octopus is one of those that the divers really, really like. Okay, there's also gooey duck. Okay, well, I'm really running out of time. I knew I would. This is our site, what ended up being our project site, and what I want to point out is over here is the little area that we were going to build the reef in. And this is the way that landscape architects think. They go off they think out in scales. And so what they've done is put together this entire analysis of the historic creek, where the fish fish passage barriers are, and really relating and understanding the relationship of this creek to our potential site. Our client didn't care at all about what was going on in the river, and it actually took the students to bring that to our client, which was the Dive Association that got this $500,000 grant. And we were really able to convince them about how important it is, this connection between the land and the reef. So this site, believe it or not, here comes the seagrass. Finally, in my discussion, it's up here at the top. And one of the concerns of our state government was to build this reef that we may impact not only the seagrass, but the geoducks that I quickly jumped over. So it had to be at the forefront of our discussion, even though our client really didn't think much about eelgrass. They said, oh, it's up and away, it's not going to matter, it's not going to affect it. And through interviews with the scientists, the students really understood that relationship between the seagrass and the river and the seagrass and the reef and started to put all of these systems into context. Here's kind of what the dive site looks like right now. Basically, divers go and trash stuff off the reef. It creates amazing habitat. But Puget Sound is, they're really trying to restore it. And so what they've done is started to remove all of this trash, which has removed a whole lot of biodiversity. And no one is noticing that more than the divers. So that is where the project was derived from. So we ran a whole bunch of public meetings. We did a lot of site analysis and water quality analysis. And came to quickly design, sorry, I've totally ran out of time. Mostly all of the goals had to do with the environment. I just wanted you to understand how powerful it was that the students and the department supported this work. So this is the design they finally came up with. And what it is actually is really amazing because it's a fluid design. So they design these sort of routes that the divers might take, but it's actually meant to be incrementally, could be added to or taken away. So it's so with the limited budget that they have, it actually seems like a lot of money, but trying to build in the coastal area, you can quickly run out of money. And so the beauty of their design, which the divers never thought of, was that this could be an additive process. So I will quit talking, but we came up with a lot of really amazing stuff. These students are so talented. And this type of visualization really speaks to people outside of science. So even though all of this was informed by science and scientists and interviews with policymakers, it wasn't until we started to put these images out that the rest of the public really grabbed on. And now we have a couple of news articles and possibly a new magazine article coming out next month. So that's it. And they came up with this cool plan for when we have total inland intrusion of the sea and how we could sustainably deal with that, but that's outside of the seagrass thing. So I'll just stop there and see if there's any questions.
Okay, thank you, Brooke, for the impressive talk. All right, we have 2 minutes for the discussion, and if anybody has... Yes, Gary?
I really love the fact that it looks like you've actually put the dive reef outside of the seagrass.
What's that?
It looks like you've got to swim through the seagrass to get to the dive reef.
So the students actually relocated the current dive entrance to this park to not only avoid the seagrass, but to avoid this other sort of critical underwater, it's destabilized sediment in the water. So they're not removing that entrance, but they're sort of making a really happy entrance somewhere else that's more desirable. So that's one of the things that they're able to do and put forward in their plan. So yes, another way.
So what is the actual reef going to be made from? You showed a range of materials there.
Right. That's part of that fluidity of the design and the budget. So one of the things that they really explored we had one student, Fatima, who was really intrigued with materiality, and we actually went to the Department of Engineering and looked at 3D printed materials. She was really interested in ceramic printing to get that complexity in the surface of the reef material. And due to the cost of that, we realized that we were going to have to either keep that in kind of a localized area, and that's actually one of the pieces I really couldn't speak to was the plans for citizen science and to improve scientific investigation capacity. So I'm sure, Gary, you would know a few of these people, but like Cy Simonstead, Megan Diether, Billy Sfala, and Tom Mumford were all took the time to come and visit us and give us information and kind of bless this project. And what that does actually, when the scientists can get involved on that level, it's not something that we think of every day that we need. If somebody asks you, hey, we're going to do the seagrass project, you kind of go, oh, okay, yeah, I do this every day for work. But actually, they came out on a Saturday and sat with us for 2 or 3 hours going over the plans and what we thought. So we got to this structural complexity, and that led us to the material complexity. And so to save money on time, we actually located a whole bunch of sources for like trash materials that like the manhole covers and kind of industrial stuff that weren't to spec, or they just end up in the landfill. And they found a way to utilize that to build this reef in a way that they could expand the size of the reef significantly from what the $500,000 might have really gone to in the beginning. So does that answer your question about material? The whole bunch of materials, basically.
It's really good to see the sort of the thought processes that you've developed here. And we're building artificial reefs at home out of a mixture of enviro concrete and other materials like that, but not using rubble.
Yeah, rubble's expensive. Mining the rock is expensive. Transporting the rock is expensive. So utilizing things like these old wells, they couldn't be sold, and so we can put them underwater. And the life just grows. I guess that was the basic message was something's good. There's nothing there, something will grow. And if we're protecting the geoducks and the seagrass at the same time, it's sort of a win-win for everybody. It's a real happy, good feeling project. And we actually had the state senator come out as well and kind of bless this project. So it's gained a whole lot of traction, and I think the success of that is coming back to the science in action, is that we've involved a whole lot of different stakeholders and put their input in. And the great thing about landscape architecture is not us saying this is what we want to do and we're going to do this. It's saying, hey, Gary, we want to build a reef. What do you think? What do we need to worry about? I know you study in this area. What would you be concerned about? What should we think about? And that is how we really built, I think, the integrity into this project that has allowed it to be so successful. It hasn't been built yet, but...
Okay, Brooke.
Thank
you
guys.
for presentation, and I also thank all the other